Welcome, everyone. My name is Carmelo Sansone. I'm actually a guest here because I manage the American regions. I work for Renesas. I've been here in the past. Actually, I was in charge of the MEMS and sensor industry group, so I've been traveling. I used to travel a lot. For those who are into the sensor world, probably you've seen me in Grenoble with many events there. But now I'm back into product, into the trenches. The goal for me today is to tell you a little bit about from tiny machine learning from concept to reality. I work closely with customers across different type of verticals, mass market, distributors, and so forth. So I would like to bring a little bit more better perspective of what is working, what is not, what is trending up, what is not trending down, and so forth. First of all, let me tell you that tiny machine learning is no longer a futuristic concept. Most of you knows what is this. This is a curve of inflated expectations. Anytime a new technology is introduced, we go through this cycle where at the beginning, so there are 5 sections. At the beginning, everyone is getting excited. We throw AI, artificial intelligence, to pretty much anything you can think of. Everyone get excited, put everything in artificial intelligence. You reach the peak, and then at one point you go down where you finally realize that not all the possible artificial intelligence use cases make sense. So you start trimming down the use cases, and then at one point you actually start developing some product that make more sense. Now, I don't have the animation here. I've already given you the answer, but raise your hands if you believe we are on the first section. Who believe you are still in the first sections? Anyone? Are we on the peak? Who believe you're still there on the peak? Anyone? Well, I've already given you the answer. Here's this one, because the animation is not working, but so pretty much some people might believe that we are also on at the bottom of this curve, and there is still a chance to grow. So one thing that come back from this experience with artificial intelligence is that not all the use cases require artificial intelligence. In fact, this slide is actually telling you that there are some use cases where the traditional programming approach actually is better suited for that use case. So when do you need the artificial intelligence? So in a nutshell, is when you have a machine that runs, and at one point, this machine is not behaving in the same way it was behaving before. So it starts developing anomalies. So it's very hard to actually solve that problem using the traditional approach. So this is a common thread among all those applications where artificial intelligence makes sense. So why there is so much interest on tiny machine learning? Why is tiny machine learning so big? What is driving all this interest? So if you look at this slide, it shows that the trend of data, volume of data information created, captured, copied, transferred, is actually growing exponentially, where we are reaching the point, we are in 2014, we are generating 10 to the power 21 zettabyte. I couldn't figure out what zettabyte is. Pretty much it's a huge number. It's kind of close to infinity to me. So we are generating a huge amount of data. So where these data are coming from, first of all? So if you think about, for example, the iPhone, so if you look at the iPhone 5, you had 3 sensors. So you have a stream of data coming from all these sensors. But now if you look at the latest iPhone, the iPhone 15 and so forth, it has from 12 to 15 sensors. So each of those sensors generate a stream of data. If you look at the autonomous driving car, the Tesla, the Waymo, the Robotaxi, the Tesla has close to 12 cameras, all are deployed along the body of the car. All the other automotive self-driving car, they have LiDARs, they have temperature sensors, a proximity sensor. And if you go into the robotaxi, where they also need more sensors to make sure that the car knows exactly the environment around the cars, you have close to 22, 23 sensors. So you have one car generating with 23 sensors, each of them generating a stream of data. So you have a huge number of data. So we are dealing with the fact that we have all these devices generating all this data. And there is a convergence between huge amount of data on one hand and processors. They are becoming cheaper and more powerful. So you have these two trends converging. So that's why there is so much interest, because artificial intelligence is a technology that was around 20, 30 years ago. And now what's happening is that when these two converge, you will have a situation where these devices will become smarter, become more useful. And that's what we are assisting right now. So that's why there is so much interest. The convergence of these two trends will generate these devices smarter, smarter, and smarter. So there are many market research, and I have to tell you, at Renesas, we pay so many market research, and they do a good job when the market is well established. However, when we deal with the emerging market, they can't throw stuff left and right. And now that's the situation with the tiny machine learning. I just use this one from Grandview Research, just because it's kind of aligning a little bit better with the topics I'm going to show to you in the next few slides. But here pretty much it tells you, okay, there is going to be the average semiconductor market is growing on the average of 6-7% CAGR. Here we are saying that on the average of these four buckets, they are growing on the average of 40%. So compared to the average semiconductor growth, these are the one where there is a promising growth. And the market is very fragmented. However, there are clusters emerging, and that's why I captured this, because it kind of line up with what I see also on the marketplace as well. Machine learning, this one is the one that you run on the cloud, so it is not of interest for the crowd here. So computer vision is when you couple cameras with processors that are able to process vision. So these are, I'll show you some success stories or use cases, but pretty much, this is used in different applications, such as when you need to detect defect on a conveyor belt, video surveillance, when you need to detect, for example, if there are some significant events, crime in action, and so forth. Real-time analytics is the combination of MCU or MPU with the different type of sensor, where it's mostly low bandwidth sensor, like an accelerometer, a gyro, and so forth. Context awareness, what that means is that as you couple these processors with sensors, they become aware of their surrounding, context awareness. Natural language processing, so this is the evolution of using artificial intelligence for human to interface machine using voice. So in the past, the limitation of this technology is that you're limited to use a very small amount of words, and you need to remember those words. Other challenges as well, noisy environment, but now I would say the technology is very robust at the point where if you set a specific set of voice commands, they do a good job. However, people don't remember those voice commands. So we are moving toward the more natural language processing, where you say, coffee machine, give me a coffee, he understands. Of course, some people say you don't want to really entertain a natural conversation with a coffee machine, but at least you still need to box that use case that makes sense. So a lot of growth among this area, and these are the three areas that we would like to focus on moving forward. And the idea here is that each of these three will actually have an impact across all these segments: healthcare, transport, logistics, home automation, consumer. Each of these areas will have a significant impact. So this technology will disrupt all this segment across various domains. Repurposing technology we are already accustomed to use. However, the topic here is also the fact that you cannot consider artificial intelligence on its own legs. So it has to be a complementary to a technology that's already established on some of the applications. Case in point, for example, motor control. There is already many companies using motor control for their own purposes. You cannot go in the motor control and say throw everything out the windows. Now it's all about our machine learning. It's actually the other way around. It's more like how artificial intelligence complement a technology, an application that is already established there. So when I go and visit those accounts, I say, look, you're doing HMI, why don't you use artificial intelligence? They tell me, look, first of all, I don't want to change the PCB. How much? Then you ask me to add more sensors. So how much is going to cost me those sensors? So now those are the type of conversation I'm having with these customers. So they need to be complementary, and they need to kind of understand that some, I would say, applications are already established. They need to work together. So these are okay. So going back, so there are three major pillars. So I'm going to talk a little bit about the success stories where we are seeing that there are applications we are actually going to production with this type of applications across voice, real-time analytics, and vision. So I'll focus first on real-time analytics. So the first example is a washer that at one point this washer started wobbling around. That's a clear use cases where artificial intelligence actually makes sense to use because you actually detect these conditions. You have two actions you can perform once that issue happens. One, you can actually notify the user there is a problem, and the other one, you can actually slow down the motors. It's a clear use cases of how artificial intelligence makes sense. So the next one is e-bike chain deterioration. E-bike is becoming very popular, but one of the problems with the e-bikes are actually two things: the battery, and you don't want to deal with the breakage of the chain because it's not a very nice thing to deal with. Again, artificial intelligence can help to detect these conditions before the chain break. The next one is arc fault detection. So it's a condition where the contact, this is industrial use cases where you have wires connected to switches, so there is corrosions, and you start having arcs, and it becomes, for those who actually turn on and off those switches, it becomes a health hazard, or a fire hazard as well. The other application trending up is battery health monitoring. So we use real-time analytics to monitor several things. There are two major interests on this field. One is how you can monitor the health of the batteries so that you always optimize the charge. And the second one is some of these batteries, they actually go on fire. So they go into some type of runaway conditions, and they go on fires. You can actually use artificial intelligence to monitor the health of the batteries and how the batteries recharge to anticipate that problem from happening. And the last one on this real-time analytics is HVAC that predict their own maintenance. So here we have several elements operating inside an HVAC. You have motors, you have filters, and the challenge is sometimes you don't know if the filter is clogged. And you can actually use sensors that monitors the filters with artificial intelligence to detect that condition from happening, as well as detecting if the motor is about to fail. Let's switch topics, and now we move into vision. So this is where we are seeing some traction. So you have these bottles going in a conveyor belt, and you see there are two actual things you want to monitor. One is whether the cap is cracked. They go at very high speed, so they really need to do inference at very fast speed, on the range of milliseconds. And the second thing is actually, if you look at the liquid levels on those bottles, sometimes the level is not correct, or it's too low, or maybe it's too high. You can detect those conditions and not making actions. Pretty much you discharge those bottles that don't fit that profile. Home building people counting. You can actually use cameras to understand how many people are coming in and coming out from a building to assess building occupancies. Sometimes this can be tied to home building automations for HVAC optimization to understand how much you need to pump up the HVAC, as well as for safety reasons. So you want to know if there are some people left in the building, if there is like a fire alarm, for example. Smart appliances, smart refrigerators, this is an area where we have been dealing with several types of applications. I showed before on the real time the washer and dryer. This is an area where you can actually put the cameras inside the refrigerators. It tells you, if you're running out of milk. It's just a clear sample. But other use cases is actually you can put the same camera on the oven. The artificial intelligence can help you to tune the cooking cycle a little bit better. So you don't have to juggle with all those buttons and figure out, okay, how I'm going to cook my cake. So you understand exactly what cake is it, what is the cycle you need to go through to actually optimize the cooking of the cake. Not just in terms of temperature, but also in terms of timing. So, okay, that's one interesting use case. I skip this one, retail queue management. So you have these folds. So you have all these people on the counters that, you have these folds that are queuing up. And if the queue is too long, you automatically dispatch a new clerk on the counter. So you can actually, improve the user experience of those going to the store. Industrial warehouse, a lot of activities in the US around the warehouse, with the Amazon pretty much dominating the warehouse department. There is a lot of automation going on this field. So this is an example where there is robots moving box left and right, and now there are several technology going there. But again, it's a combination of vision, but there are also they use also other sensors such as a LiDAR, or they also use a positioning type of technology where they need to understand at any given time where exactly the robot is located. Smart city activity detections. So this is something that is relevant to smart cities, where on smart cities there are several applications, but the one that is really trending up is the fact that if there is it's very large territories. In some cases, you have a camera that actually tell you, look, there is a crime in action, and they understand there is a crime in actions, or maybe there is some significant event. Maybe there is a fire happening in that location. So they dispatch a policeman or a fire brigade very quickly. So the last of these set of success stories, the voice. As I mentioned before, most of these success stories you can actually set a very small set of voice commands to turn on and off certain things. Like a thermostat, you can turn up and down the temperature. And it can also be used for glass break detection for home safety. And for this one, the requirement is a little bit different. For this one, it's less power requirement. For this one, the power requirement is stricter. So you have to deal with all these also issues in terms of, okay, what is the power budget for this application? So this one is to operate on a battery. This one as well depends on the legacy of technology. Some thermostat needs to be hooked. They have a battery, some type of thermostat. They are actually connected with the HVAC in the US. I'm not sure about in Europe if it's a different setup. But the battery, I would say the power management requirement is a little bit less stringent than it is for the security. Smart appliances, pretty much any devices that you can think of can be interfaced using voice. So this is a new solution that we are creating is for smart building automation. So in order to gain entrance in a building, it is possible actually to authenticate a person from a voice, combination of face, voice. So this can be useful not only for gaining entrance in the building, but also for improving the user experience for washer and dryer, thermostat. Because one problem we have with this thermostat when you add voice is then you have a key that actually can turn it down, up and down the temperature. No, it's something you want to avoid. So this actually what it can do is authenticate the user first, and then allows you to gain access to the interface. Voice is becoming more and more robust. In fact, there are also artificial intelligence solutions that are going to replace the traditional noise cancellation approach using a DSP. And that will allow voice to actually enter into the industrial world, which typically is a very noisy environment. Smart light and smart switch. these voice artificial intelligence are being so optimized, they can run on microcontrollers that cost on the range of $1, so even less. And they can actually, if you save a 3 or 4, 5 voice command, you can actually run that artificial intelligence models on the 50 cents microcontrollers. Okay? 3 use cases, 3 set of use cases: voice, real-time analytics, and vision. And now the challenge is this: okay, we have all this technology. So what is stopping us to push this to mass market? So what are the key barriers for us to actually deploy artificial intelligence to a large set of customers? So first of all, lack of skilled laborers is on top of the list, 36%. Data access handling is the second one, limited budget, deployment into the system solutions. So the lack of skilled labor is actually it's quite challenging because the academy, university are not really keeping up with what is needed in the field. So I have a company that are really struggling to hire people. They are expert on artificial intelligence. But one challenge that I would like also to emphasize is that, so there is the problem is that everyone focuses on the artificial intelligence model, which in the end actually is only 5% of the problematic customer face. So the rest is all, how are you going to make this work? In other words, where you get the data? What tools you use to get the data? What data you need to collect? Where do you put the sensors? How many sensors you need to put on the machine? How you validate for sensor data good or bad? And then you start building some confidence building models. So in other words, these only 5% of the activities related to artificial intelligence models is only 5%. The rest, 95%, is actually hard work, engineering, hardcore job work. So this brings us to a Renaissance vision, which is we want to remove all these barriers, and we want to make it. We are creating this scalable infrastructure that allows us to kind of meet the demand of the new generation of customers, creating a scalable offering and with different multi-layer developer stack. So scalable ARM portfolio. So this focus specifically on ARM, but the topics of this slide is that, you have a different type of processing capabilities. Sometimes the challenge is that, a lot of people go straight into, I need, 80 tops, 50 tops. So we get excited about, technology that push the envelope of the latest and greatest artificial intelligence acceleration technology. However, right now, all the success stories that I showed you before, they're actually hovering very small brain. This brain here, which few layers here, they actually do a good job with the switch. They do a good job with the washing machine. This one as well. These actually start doing the motor check or predicting maintenance. So around here. So I would say it wouldn't be an Einstein brain. It would be a brain that a typical average person. And then as you start moving into this other one, so we have created a processor that kind of like a bridge, the NPU. So the last one is the NPU. This other one is the microcontrollers, where you have more capabilities. You start doing vision with microcontrollers. So low-cost microcontrollers, you can actually do simple real-time analytics. You can do voice commands. Again, why you need 10 tops if you can run the same, you can be successful using 50 cents per microcontroller. There is no reason. So you can do a larger set of voice command on voice, or more real-time analytics complex tasks. You don't need, you can actually use a Cortex-M33 base microcontrollers. So this one we just launched recently. I'll provide more artificial intelligence accelerations. But what we need this for? So why you need more powerful microcontrollers? Because you start seeing more advanced artificial intelligence stuff, more advanced real-time analytics, more video object detections, You see the path of application I showed before. You can actually run these on Array 8 successfully in a certain time frame. You can do now natural language speech recognition, interactions with the machine. So that's why you need more powerful, but only for those use cases. For all the others, and there is a large, the one I showed you before is just a very small set, but there are a large set of use cases where this microcontroller is good enough. And then, of course, and now we get excited. So I need 80 tops or 10 tops, where that's in a few cases where you start adding more and more cameras. You need to do you have a multiple video feed. And there, for those use cases, you need a processor that needs to accelerate artificial intelligence type of algorithm. So this is for your understanding. Array 8, better performance for artificial intelligence compared to the previous generations. So this is an application where before you only need to use an NPU. And again, the reason why we need a faster microcontroller, more powerful microcontrollers, we can do this if you're okay if we do this with 80 frames per second. The microcontrollers, this is a good fit. So this can be used, for example, for the Ring cameras. I'm not sure if you guys use Ring in the EMEA, but there are those small cameras that can be used to detect if something is coming close to the door and turn on the video cameras. This does a good job. You don't need an NPU, which, by the way, we also do NPU. So it's we are competing within our own company. But I'll tell you the sales team. So if the customers tell you, look, the 8 frames per second is good enough, sell a microcontroller. Don't sell an NPU. Why you want to pull them through a more complex architecture and technology? Of course, we have also the 80 TOPS NPU. So we have our own DRP technology that allows us to do pre-processing, inference, and post-processing. Now, today, I don't want to go down into the technology itself. I leave that to, we present this to customers, but for you, I would like to keep it at a higher level. We say, okay, we have a technology. This is a side-by-side comparison between an NVIDIA processors with our processors. So you see that we have our claim to fame is 80 TOPS or 10 TOPS per watt. So we are optimizing our architectures for low-power applications. So these are applications. You see the performance are even better than a comparable NVIDIA's processors, but the power consumption is 14 times less. So I hope I don't shock anyone. At this point, I expect everyone at Tiny Machine Learning should know what is the difference between the traditional model of programming and the tiny machine model of programming. So just for putting everyone on the same page, traditional model is use data and rules, push them into microcontrollers, and you get results. On the tiny machine learning, you have this, you need to do this, you need to sample the data, you need to figure out what you expect, what are the results expected for those data, use a server, or in some cases you actually have the generation of the models can be also done. If you have a very powerful data centers in-house in the building, you can actually do that without paying for the cloud services. It can be done by yourself. You generate the models. Eventually, you push this into the processors, and you get results. Now, just to state, the process of developing an end result with the tiny machine learning is quite different from the traditional model. So why I'm saying that? I'm saying that because we are trying to simplify this process. So pretty much what we are doing is we have development tools that allows you to collect those data. And last year, we acquired a company called RealityEye that specializes on real-time analytics generation or artificial intelligence model. But if I go back into 3-4 slides where I share, look, the AI machine learning model is only a small portion of the challenges customer faces. So what we're doing, we're actually integrating the overall chains of development with our development tools. So we collect the data using Square Studio, we process the data with Square Studio, and then finally we use the models that we have, the tools that we have inherited by the acquisition of RealityEye. And we do the training models, we do export the models, and then we go back into Square Studio again, and eventually we run into a real physical hardware. So this is the process how we are trying to streamline and how we match the processes I showed before. Now, I focus only on real-time analytics. If I have to touch also the vision and voice, it would take, other 2 or 3 hours. But voice and vision also have the similar challenges. It's not just the generation of the artificial intelligence model, it's also how you get the data, how you process those data, what tools do you use, who can help me to get those data, and who can help me to understand what models I need. I mean, these are the typical customers' questions I get. And I have 2 types of customers. I have customers who know that what they need to do with artificial intelligence, they have hired a large set of artificial intelligence engineers in their house, so they know exactly why they need artificial intelligence. And then I have customers, they say, I have no ideas, but my manager is telling me I have to use artificial intelligence. So each of them has a completely different dynamic. And we also use partners sometimes, for example, for vision and the real-time and the voice. We actually sometimes pull partners in and say, look, this customer is focusing on defect detection on the conveyor belt with the one I showed before. Can you help them out? Or if a customer knows how to use the tools, we can actually tell, look, if you want to use our tools, we have a different way to use our tools, including the fact that for vision, for example, there is a lot of pre-trained models available in the open source community, and some customers like to start from those models because they can save some time. That's my last slide. So in summary, tiny machine learning is no longer a futuristic concept. It's gaining prominence. But no, you cannot throw artificial intelligence to any problem you can think of. So, but now you can start seeing that there are some applications where it makes sense to use artificial intelligence, but don't be afraid to push back. Say, look, this use case you're bringing, artificial intelligence make things worse. It's going to be more costly and more complicated for you to develop it. So there is a significant growth in tiny machine learning adoption. I explained the reasons, driven mostly by the exponential growth of data generation and data transfers, data copy acquisitions. Benefit of tiny machine learning include the real-time analytics, improved vision application and voice. Key barriers to push artificial intelligence to mass market, of course, are we need more people with skillful engineers who know this stuff pretty well. But we also saw that a lot of people focus a lot on the generation of the model itself, and we forget that the journey is pretty long, and it's not just the generation of the models. Our goal, the vision of Renesas, is to bring artificial intelligence to mass market and make it easy for our customer to adopt it. And we have created a product portfolio that allows you to use vision, voice, and real-time analytics in a scalable manner. What that means is that we create these tools that work across the whole spectrum of microcontrollers and processors that you can actually, once you find the right fit, we can give you the most cost-optimized microcontrollers and processors. We have a comprehensive developer stack. I showed before really quickly. But that's my last slide. Thank you very much.